Good morning, guys. All right, so we are moving forward in the Math 20 Radicals unit, and the topic we're doing is called multiplying and dividing radicals. So just a bit of review from what we covered in our last lesson. If we have root 2 plus root 8, we're not allowed to add these two radicals the way they're written right now. Okay, so if it's an addition or a subtraction like that, you're not allowed just to go and say this is not equal to root 10, for example. Okay, so you can't just go 2 plus 8 is 10 like this. But what we can do is we know that root 8 is the same thing as 4 times 2, and that the square root of 4 is 2 root 2. So this is like a 1 root 2 plus 2 root 2 is 3 root 2. Okay, so we're allowed to do this. Okay, this is a review from our last lesson. But if I have root 2 times root 8, I am allowed to multiply these guys over here. So root 2 times root 8 is the same thing as 2 times 8 is 16. And now square root of 16 is just equal to 4. Okay, so I'm allowed to multiply root 2 times root 8. So when you're multiplying, you can multiply them like this. When you're adding, you have to simplify it first and then add or subtract like radicals. So here's the kind of questions you're going to see in this section. Okay, you have like a multiplication statement, so 4 root 3 times root 6 plus 2 root 5. So what we want to do is just same thing that we kind of use our distributive property to multiply this. I can multiply 4 root 3 to this term and to this term. 4 root 3 times root 6 is 4 root 18. Plus, now if I'm multiplying 4 root 3 times 2 root 5, let's move this off the side here, 4 root 3 times 2 root 5. The rules are we can multiply the coefficients together. 4 times 2 is 8. And we can multiply the radicals together. Root 3 times root 5 is root 15. So we can get like this. Okay. Now we're partially done though, because we can still simplify this radical. We can't. There's nothing we can do to root 15. 15 factors to 5 and 3, and neither of those are going to be perfect squares, so we can't reduce this radical anymore. But 18 we can. It's 9 times 2, like this. Plus this stays the same, and now square root of 9 is 3, and this is 4 times 3. And we still have this root 2 underneath, plus 8 root 15. 4 times 3 is 12 root 2 plus 8 root 15, like this. Okay, so here's going to be our final answer for this question over here. Okay, so now it's going to be like 2 terms times 2 terms, so a binomial times a binomial over here, radicals. So we're just again following our distributive property. This root 2a has to be multiplied to both terms in this sets of brackets here, and the root 3b has to be multiplied to both terms over here as well. And this is how we multiply 2 terms times 2 terms. So root 2a times 7 root 6a is going to be, so there's like a 1 here, 7 times 1 is to 7. Root 2a times root 6a is 12a squared, okay, minus 2. Root 2a times root 6b is 12ab, plus this term times this term, the 7's out in front, 18 root ab, oops, no root there, it's going to be 18ab like this, and we have minus, so there's the 2 times the 1 is going to be minus 2, and we have root 3b times root 6b is 18b squared. All right, so this is going to be 7 times 12 is going to be 4 times 3. I'm just going to leave this here for the moment, this a squared, minus 2. 12 is the same thing as 4 times 3, so 4 times 3 ab. 18 is going to be 7, it's 9 times 2. Minus 2, 18 is 9 times 2b squared. So here, I can pull out this is square root of 4, and this is the square root of a squared. 7 times 2a, and I'm left with this root 3 here. minus, this 4 can come out. So square root of 4 is 2, so it'll be 2 times 2. And this is going to be a 3ab. Square root of 9 is 3. 7 times 3 root 2ab. Minus, square root of 9 is 2 times 3. Square root of b squared is b. And I'm still left with this root 2 inside there. 7 times 2a is 14. A root 3 minus 4 root 3ab plus 21 root 2ab minus 6b root 2. Now there's nothing else I can really do to this one. Okay, these guys are close to being like terms, but the fact that this is a 3ab and this is a 2ab means we can't add these guys together because they're not like radicals over there. Nothing similar over here. So this will be my final complete answer for this. Okay. So just this question over here. Now it's very tempting just to square this guy and square this guy, but we can't do that because that's not what this type of square means. What this means is we go root 2 plus 7 root 5 times root 2 plus 7 root 5 like this. And now we need to use our distributive property. Multiply through like this, and multiply like this. Root 2 times root 2 is root 4. Root 2 times 7 root 5 is 7 root 10. Plus over here, we have 7 root 10. Plus 7 times 7 is 49 root 25. Square root of 4 is 2. 7 root 10 plus 7 root 10 is 14 root 10. And then we have 49 times 5, because square root of 25 is 5, plus 49 times 5. So this is 2 plus 14 root 10. 49 times 5 is 245. And we can add 2 and 245, so we get 247 plus 14 root 10. All right, so here's our final answer for this guy over here, okay? All right, so multiplying this guy over here, it seemed very similar to the other ones we've done over here. Now, these two terms look the same. This is root 10 plus root 3, root 10 minus root 3. We have a special name for these types over here. We'll talk about those in a sec, but see what happens when we multiply these. Root 10 times root 10 is root 100. Root 10 times root 3, negative root 3, is negative root 30. Root 3 times root 10 is positive root 30. Root 3 times negative root 3 is negative root 9. Root 100 is 10. And then negative root 30 plus root 30, these two middle terms are going to cancel out. So those guys kind of disappear. And then root square root of 9 is 3. 10 minus 3 is 7. Okay. So we have a special name for these guys over here. Root 10 plus root 3 and root 10 minus root 3 are called conjugates. So this is the mathematical term for these types of guys up here. Now the idea is like, just off to the side here. If you remember from like math 10 where we're factoring, like how do you factor a squared minus b squared? Well, the answer to that was this is a difference of squares. It goes to a plus b, a minus b. So the idea is like a difference of squares always factors to the product of conjugates. Okay. Now this is convenient because later on in this lesson we're going to talk about how do we get rid of square root signs when we need to, and the answer will be multiplied by conjugates. Okay. Example 6, divide. Root 80 divided by root 2. So the same way that when we're multiplying, we can you can multiply them. Well, this is the same thing as if I'm dividing this by this like this, which one radical divided by one radical. I can just make this 80 over 2 in one radical like this. Now 80 divided by 2 is 40. This is the square root of 40, which is a square root of 4 times 10. Square root of 4 is 2. root 10. Okay, so this is my final answer over here. Okay, so just in summary, we kind of combine these into one radical like this, and then I can just divide them normally. 80 divided by 2 is 40. The same way that is if I was multiplying, you can divide them like this, and then we want to simplify the square root of 40, like we learned in our last lesson. Okay, so example 7. Instructions say evaluate and calculate round 4 decimal places. So if I go 2 divided by square root of 2, I get 1.4142. If I go square root of 2, I get the exact same number, and this is just rounded 4 decimals, is 1.4142. If I go square root of 8 divided by 2, I get the exact same thing as well. So reason why I like showing this example is that we have 3 different expressions here, which all equal the exact same thing. Okay. Now the thing is, all 3 of these expressions, they look very different. Okay. And so because of that, well, if they all equal the same thing, we need to have some standards to kind of be able to go and say, well, why do they all equal the same thing, and how do we grade this? Well, we talked about how to do stuff like this. Root 8 is the same thing as 4 times 2 like this, and the square root of 4 is 2 root 2 over 2, and these 2's cancel, and this root 2 is the same as this root 2 over here. Okay, now we'll talk about this more in a second. Here's how we here's how we make this guy the same as this guy. What I'm going to do is I'm going to multiply. If I multiply something times the top and the bottom by the same thing as multiplying by 1, which means we're not actually changing anything. What I'm going to do is multiply this guy by root 2 over 2. Root 2 over root 2. So what that gives me is 2 root 2. Root 2 times root 2 is root 4, which is 2, and those cancel out, and that's how this guy equals 2 as well. So one of the reasons why we simplify radicals like this in this situation is because we want this to be like this. This is the simplified version of this one over here. Root 2 is also the simplified version of this expression over here. Okay, so that's how we're able to get it like this. So the standard we have is, well, we want to be able to simplify radicals when we can, and when we have square roots or cube roots or anything in the bottom, in the denominator of a fraction, the term we call it is rationalize the denominator, and that means we want to get rid of any square roots in the bottom of the fraction and only make them in the top. And that's kind of the standard that we use for radicals. So example 8 says rationalize the denominator. Okay. So what I'm going to do over here is I'm going to multiply the top and the bottom times root 3, like this. And that gives me, okay, so what that gives me is going to be root 3 times root 3, which is root 9, and square root of 9 is 3. And that means we have a 5 root 3 in the numerator like this. So I know this does not look simpler, but we have a rational denominator. So I mean, this is now a rational number, not an irrational number. Okay, so this is the standard that we use called for rationalizing the denominator. This is how we do it. Similar idea here. I can go times root 10 over root 10. That means my numerator becomes square root of 60 over root 10 times root 10 is root 100, which is 10. Now, 60 is the same thing as 4 times 15, like this, and square root of 4 is 2 root 15 over 10. And now I can simplify this fraction over here. 2 over 10 is the same thing as 1 over 5, so I'm just going to put like a 1 over 5 like this, which becomes root 15 over 5, and this is the simplified version of this answer over here. Okay, example 9. A little bit more tricky here. Now, the idea is, like, unfortunately, this is not going to work here. If I go like this, well, that's going to give me 5 times the cube root of 4 over the cube root of 16. Now, 16 is not a perfect cube, okay? So it's not going to work this way as well. So this is not going to work, unfortunately. So what I'm going to do instead is I want the bottom to be a perfect cube. Well, I know that the number 8 is a perfect cube. So if I multiply the top and the bottom by the cube root of 2, okay, what this is going to give me is 5 cube root of 2 over the cube root of 8. And the cube root of 8 equals 2. So this would be the answer for this guy over here. Okay, so again, for cube roots in the denominator, we want the denominator to become a perfect cube. And so we think, well, what do I need to multiply by in order to get a perfect cube over here? Okay, so example 7, rationalize the denominator here. So for a question like this, this is actually quite a bit more difficult, but I'll show you the wrong way first. First thought is, okay, well, let's multiply by this. Okay, the trick is I have to multiply this times both terms. So if I did it this way, my answer would become this. Root 7 times root 7 is root 49, which is 7, but then I get 2 root 7. So all I've done is I've moved the radical from the first term to the second term. I haven't rationalized anything. We talked about the term conjugates earlier on. So here's what we want to multiply by instead. What I want to multiply is root 7 minus 2, like this. So the top and the bottom by the conjugate of the bottom term. Okay. Now what it gives me in the numerator, it gives me 2 root 7 minus 4. Okay. In the denominator, it gives me root 7 times root 7 is root 49, which is 7, minus 2 root 7 plus 2 root 7 minus 4. So this term and this term cancel out, and we get 2 root 7 minus 4, and we get 7 minus 4, which is 3. Okay, so this is the rationalized version like this. Okay, so if we have two terms in the bottom of the fraction like this, the strategy is multiply the top and the bottom of the fraction by the conjugate of the bottom. All right, so a little bit more of a difficult one over here. We have root 2 minus 3 root 5, or 5 root 3 plus 2 root 10. So we would need to multiply the top and the bottom by the conjugate like this. Okay, so this is a plus, this becomes a minus, but otherwise the terms stay the same. All right, so there's gonna be a whole lot of work in the numerator here. So we have to be able to distribute everything in the numerator. So doing that, we get 5 root 6 minus 2 root 20 minus 15 root 15 plus 6 root 50 over 25 times root 3 is root 9, which is 3 like this, minus 10 root 30 plus 10 root 30 minus 4 times 10. Now it's 4 times 10 because it's 2 times 2 is 4. Root 10 times root 10 is root 100, which is 10. So clean this up a bit. We get 5 root 6. Now what I'm going to do over here, root 20 is the same thing as 4 times 5, like this. So I'm going to simplify as I go here. Minus 15 root 15 plus 6 root 5. On the bottom, these two middle terms cancel out. 25 times 3 is 75. 4 times 10 is 40. So we get 5 root 6. Root 4 is 2 times 2 is 4 root 5 minus 15 root 5 plus 6 root 5. 15 root 15, there we go. 75 minus 40 is 35. All right, so a little bit more, 5 root 6 plus, negative 4 root 5 plus 6 root 5. I can simplify those two. So we get 5 root 6 plus 2 root 5 minus 15 root 15 all over 35, like that. And that is my simplified answer. All right, guys, this was quite a long lesson. Thank you for sticking with me all the way through the end. And as always, guys, please send me a message if you have any more questions. Thanks.